In this lesson, we are going to begin our fraction section. So this section is going to be fraction basics. So we're going to cover writing equivalent fractions, simplifying and reducing fractions, as well as converting between mixed number and improper fractions. Fractions are everywhere. We see them around us all the time, especially if you're working in the trades, in spite of the fact that Canada is supposed to be a metric country. We still use inches on our tape measures. We use inches often to do bolt sizes for nuts. I mean, we use both of them, but you'll often see inches and fractional measurement there. You'll see fractional lengths and sizes for screws. Fractions show up in a variety of places, and for that reason, we have to make sure that if you're working in trades, whether you're working in carpentry, HVAC, automotive, any of the trades, you're expected to know how to work with fractions. So that's what we're going to work at covering in this section, is the basics of what you need to know to work with fractions. This is part of a 4 or 5 lesson, I forget the exact number, series on working with fractions. First of all, we're going to cover some basic terminology. So when you're working with fractions, the upper number, so I'm going to switch my mouse here to a pointer. So the upper number, the top number, is called the numerator. The numerator stands for how many pieces in a set we have. The bottom number is called the denominator, and it is how many pieces belong in a set. So in this case, you have 6/10. Graphically, we can represent that using a set of 10 boxes, highlighting in 6 of them to show that 6/10 are highlighted. Typically, the bottom number, when we say a fraction, we'll read the top number normal, so 6. The bottom number, we say its value with TH on the end, so 6/10. You would have heard that already when you were doing place value. Another way to show 6/10 would be 0.6. So we'll use both of those by the time we get through the first couple lessons. Some people, if you're like me, I have a slight dyslexic tendency. I'm not nearly as bad as some people are, and I don't profess to be, but if you flip things around and you have a hard time figuring out numerator, denominator, which one's where, denominator is always in the bottom, D and down, so denominator and goes down. That's what I use for a little memory trick, and it tends to work for people that have a hard time remembering numerator and denominator. So I guess I have to see if I can get this to click through. All right. So I'm going to look at another fraction here. This is what we refer to as a reduced fraction. So the first fraction shown in the picture here is what we refer to as 6/16. So there are 16 pieces. We have 8 on the top and 8 on the bottom. We've got 6 of those shaded in, so that gives us our fraction 6/16. Now, typically, we wouldn't say 6/16. This is some number that you could read off your tape measure. A lot of tapes are marked off in 16ths. We need to reduce that. So what we mean by reducing it is we write the simplest way we could write it. And in order to do that, we're going to take our top number and the bottom number, so the numerator and denominator, and we're going to divide both of those by the same number. So you'll see here, we can take those 16 pieces and group into sets of 2. If we group them into sets of 2 and rewrote it, just using the bold lines, we would get this bottom picture, which is 8 pieces, a set of 8, and then so 2 pieces make one shaded square, another 2 pieces make another shaded square, another 2 pieces make another shaded square, so we get 3/8. Mathematically, in order to do that, what I do is I look at both of these and think, what can I divide both of them by? Ideally, I look for the largest number I can divide both of them by. 6 can be divided by 2, which gives me 3. 16 can be divided by 2, which gives me 8. So that gives me my 3/8. And if you look at the 3 and the 8, I can't divide either of those two numbers by the same number. 3 can be divided by 3 and 1, but 8 is not divisible by 3. And if you just divide by 1, the fraction stays the same. So 3/8 is what we call a reduced fraction. You may also see here the word simplified, so we'll pop that in here. Or you could hear the word lowest terms. All three of those mean exactly the same thing in fraction language. Sometimes when we're working on fractions, we don't need to reduce it. We need to create an equal fraction that's larger, and we can do that as well. So in this example, I've started out with 1/4. So here's our set of 4. We have 1/4 shaded. In the second picture, I still have 1/4 shaded, but you'll see I've taken each piece of the pie, and I've split it into 2 pieces. So basically, instead of having 4 pieces, I now have 8 pieces because each of those pieces is now worth 2. You'll see now I have 2 pieces shaded on top. Whatever we do to the bottom, we have to do to the top. Whatever we do to the numerator, we have to do to the denominator. So to create an equal fraction, if you're going larger, you're just going to multiply by the same number on the numerator and denominator, and that will give us an equivalent fraction. So simplifying fractions, creating equivalent fractions, both of those are essential skills when you're working with fractions. We'll cover a few rules here in a minute. So I guess my picture is too large. I find it easier when I have a little video in the corner to record lessons. And if somebody happens to need a little bit of lip reading, hopefully that small video is enough to help you out. So for this question, we're going to write each pair of fractions with what we call the common denominator. This is another skill we need to have. So we're kind of putting 2 things into one. And we're going to identify the largest fraction. Common denominator just means that the number on the bottom, so the denominators are the same. So let's look at A. We have 7/16 and 3/4. We need to write equal fractions so that the denominators are the same. When I look at a question like this, okay, 16, what times 4 would give me 16? It's usually what I will think, because I can't take 7 and 16 and make them any smaller. 7 divides by 7, but 16 doesn't divide by 7. So I can't change the 7/16ths, really. So I'll always start by saying, can I just change one fraction? If you remember your multiplication tables, this is a good time to brush them up. Mental math is going to be really helpful in this section. You will remember that 4 times 4 gives me 16. So whatever we have done to the denominator, we also need to do to the numerator. So we're going to do 3 times 4 to get 12. The 2 equal fractions will be, with a common denominator, well, 7/16 is one fraction, and 12/16 is the other fraction. The largest one, I'll just put a box around it, would be 12/16 or 3/4. When the denominators happen to be the same, you just look for which one has the most pieces. Let's look at B. B is another good example. We have 2/3 and 1/4. We need to write those with this same denominator. This is going to be really important when we get to adding and subtracting fractions. So you need to make sure you know how to do this piece. Now, I can't do 3 times something to get 4. And I can't do 4 times something or divide by something to get 3. So one of the easy tricks to use is we're going to take the denominator from this one and we're going to multiply it over here. Oops, I didn't mean to write 3. Get rid of that. So we're going to take the 3 and we're going to multiply it by 4. And then over here, I'm going to take this one and I'm going to multiply it by 3. Because if you remember from way, way back in elementary school, it doesn't matter what order we multiply in. We can do 3 times 4 or 4 times 3 and have exactly the same numbers. So let's figure out what the solution is. So 2 times 4 gives me 8 for my new numerator, and 3 times 4 gives me 12 for my denominator. The second fraction, I'll use the and symbol, it's easier than writing it. We have 1 times 3, which leaves me 3 on the top, and 4 times 3, which gives me 12 again on the denominator. So this gave us a common denominator, and the largest fraction is 2/3. Now this is one you could have picked out the largest fraction without having a common denominator using what I call benchmarks. 2/3 is greater than 1/2 because half of 3 is 1.5. Most of us would know that off by. A quarter is less than half. I think 50 cents is $1, so if you have a quarter, you've got less than half a dollar. So one's more than a half, one's less than a half. That makes it easy to pick which one happens to be the largest fraction. Now when we get to C, C is an example that's a little bit trickier to look at and see which one's biggest. 5/8, that's more than a half. And then 2/3 is more than a half. Which one's actually largest? This is when we're going to need our common denominator in order to verify. So we're going to use the same strategy we had in B. There's not really a math connection between 8 and 3 for one, use one to get the other. So we're going to combine the two together. So we're going to take our 8 times 3 and 5 times 3 on one side. And then over here, we're going to multiply both by 8. The reason we have to do whatever we do to the bottom, we have to do to the top is to keep it balanced. Otherwise, the fraction won't be equal. It will be different. So our new fraction, 5 times 3 leaves me with 15 over 8 times 3 gives me 24. So 15 over 24. And the other fraction, 2 times 8, leaves me with 16. And again, 24 on the bottom. 2/3 is the largest fraction. There's not a very big difference, but 2/3 is slightly larger than 5/8 because it's equal to 16/24 instead of 15/24. For the very last question, this takes us back to the beginning. This should be a nice easy one. We have 3/16 and a quarter. Which one's larger? Hard to tell by just quickly glancing at it unless you really know your tape measure well. So we're going to multiply the top and the bottom both by 4 to make a common denominator. This will give us 4/16. 1/4 is bigger than 3/16. So anytime you're asked to compare fractions or put fractions in an order, make all the denominators the same. Write equal fractions that all have the same number on the bottom, and then compare the size of the top. Okay? That's the easiest way to handle that. The next question we're going to do is we're just going to practice our reducing. So we need to reduce or simplify, write in lowest terms, these 6 fractions. In order to do that, remember from just a little earlier when I introduced it, we're going to take the numerator and the denominator and we're going to divide them by the same number. We cannot have decimals. It has to divide and give us a whole number. It is possible that we could have an example you can't reduce. Sometimes that's the case. And you have to kind of watch for that, and you'll just have to know when those exist. Okay? It's going to be a little bit tricky sometimes to know, am I done reducing? But I'll give you a few tricks along the way. The first example we have is 4/8. This should be a relatively easy one for you. For many people, just looking at it, you can see that, well, 4 is half of 8, so that must be equal to a half. You could put it in your calculator as 4 divided by 8 and get 0.5. That would show you that you have a half. But from a show your work perspective, which I will ask you to do when we do a test, you're going to take your top number and divide it. Now we're going to divide this by 4 because I can see that I can divide 8 and 4 both by 4. If you chose 2, you're just going to have to reduce twice. And this will give us 4 divided by 4 is 1. 8 divided by 4 gives me 2. So this leaves us with our 1/2. And I'll have to put a box around my answer just so that it's really clear what the answer is. We're going to drop down here to B. We have 6/16. To solve this one, I look at the two numbers. They're both even. If two numbers are even, you know you can divide by 2. Even numbers are numbers like 2, 4, 6, and 8, or 0. Add 0 on the end. So if you have 2, 4, 6, 8, 10, 12, So the number ends in any of those, then you know you have an even number. So we're going to divide both by 2. 6 divided by 2 leaves me with 3, and 16 divided by 2 leaves me with 8. I cannot reduce those any further. So that would be our most simple or lowest terms. For C, we have 12 and 15. Now these two, we've got an odd number and an even number. These are the ones that sometimes people make mistakes on, or they think they can't reduce them. If you have an odd number and an even number, you just need to think a little harder. My tip for odd numbers and even numbers is try, especially if it's not like a 15 and 10 kind of scenario. So if you have an odd number and an even number, try divide by 3 or 7. Those will give you odd numbers, and they're the ones that have a tendency to be hidden. Well, you look at this, 2 times 7 is 14, so 12 is not going to be divisible by 7. So let's try 3. Knowing multiplication tables is a huge help. Good thing to practice for on-the-job math. 12 divided by 3 leaves me with 4. 15 divided by 3 gives me 5. The simplest terms is 4/5. We'll go down to E. We have 8 and 12, 2 even numbers. Let's start out dividing by 2. For some of you that caught it, yes, I could go larger than 2, but I'm going to start with 2, just for the sake of showing an example. So this gives me 4/6. Now, if you look at this, the answer that we got is still even has an even numerator and an even denominator, so you can divide by 2 again. So if you don't know your multiplication tables, that's a good strategy to use, is start with something small and then see if you can keep going. 4 divided by 2 leaves me with 2. 6 divided by 2 leaves me with 3. 2/3, lowest terms. We're going to use the same strategy for E. E, the numbers are a little bit bigger, and unless you really know your multiplication tables, you might have a little harder time with this one. Usually it's easier to see what you need to reduce or what you need to divide by when the numbers are small. So the first thing I'm going to suggest that you do is pick an even number, pick 2. Pick the smallest, pick up one of the smaller numbers that you think, yeah, I can divide by that. We'll get the numbers on the numerator and denominator smaller, and then we'll see if we can go further. It's a good strategy. Divide by 2 on both. If you know your multiplication well and you can jump to the largest number, go for it. You'll get the same result in the end. So we're going to get 12. 24 divided by 2 is 12. 32 divided by 2 leaves me with 16. 2 even numbers. I can keep dividing. Hopefully you remember from before. If you don't, you would do 2 steps instead. But if you remember from before that 12 you can divide by 4 and 16 you can divide by 4, we can jump to a little bit bigger numbers. And that leaves me with 3/4 as an answer. For F, we have 12 over 21. Now this one is a tricky one because we have an odd number and an even number, and sometimes it can be hard to guess what you should divide by. But again, go back to this, try 3 or 7. So let's try 3. I usually will start with 3. More things divide by 3 than divide by 7. So we'll divide by 3. 12 divided by 3 leaves me with 4. 21 divided by 3 leaves me with 7. If you pick a number and you divide by that number and it leaves you with a decimal, you cannot leave a decimal in fractions. Fractions will always be done with whole numbers. We will look at how you write a decimal fraction. It's called a decimal fraction, but in this fraction form, your numerator and denominator will always be whole numbers. So to quickly summarize, you will always want to provide the most simplified or reduced fraction for your final answer. Every single time. That's one of the fraction rules. And always, whatever you do to the numerator, you're also going to do to the denominator. You'll notice I've written it in both places, everywhere as I did the math, and that's because it works. Students that struggle with reducing fractions often forget to write what they're dividing the numerator by and the denominator by. By just writing it in, it helps you keep track of the fact that you're using the same number both for the top and the bottom. Your fraction rule for this section, always, unless otherwise stated, always use the most simplified or reduced fraction for your final answer in questions. This will be essential for SAM quizzes. So I'm guaranteeing I'm going to get some emails from people and they'll say, but it's just not simplified. You must simplify your answers to get the right answer in SAM. It's essential. All right. This is a good spot. If you want to do a little pause, take a little break. This would be a great spot to hit pause. And then if you need to come back later, we're going to look at improper fractions and mixed number fractions in this section. The examples are fairly quick, so it shouldn't take us too long. But if you're feeling like you need a little head break and you want to do a few reducing practice questions on some of your worksheets or in your workbook, feel free to pause, practice a few of those, and then maybe come back to this section if you want. So there are two types of fractions that we can see. The fractions that we've looked at so far, they're what I call normal fractions. Common fractions. I'm not sure if they have a specific name. Sometimes I don't think about those things until we get solving. But here we have improper fraction and mixed fraction. Now these two fractions are actually equal to each other. These are fractions that represent a quantity greater than 1. You will identify an improper fraction as a fraction that has the numerator larger than the denominator. Okay, so we have the numerator larger than the denominator. So 9 is greater than 4. This type of fraction is not allowed to be in a final answer unless you're asked for the improper fraction in a final answer. Your final answer you will always give in the mixed number form. Can you imagine going to a job site and telling them I need 9/4 of an inch measured? Somebody's going to look at you and say, seriously? 2 1/4 inches? That's normal. That's how we say that. So that's one of the ways to help you kind of think about, am I allowed to leave an improper fraction? Think about, would this be weird to say as a fraction if it was a measurement? So we take our 9/4 and we put them into sets of 4. So we've got 4 here, 4 here, there's 8, there's the 9th left over, and a mixed number equivalent fraction would be 2 sets and 1/4 left over. Now we're going to figure out how to convert between these, and sometimes that's a little bit of the trickier part. We're going to first start with going from from mixed number fractions to improper, because that's the easiest version to begin with. So first, convert from mixed to improper fraction. So the fraction we have is 5 2/7. Now we could draw this out, but that's a lot of pieces to draw. And drawing it out, that's just relatively impractical for time purposes. But you could draw 5 sets of 7 and then an extra set of 7 with 2 pieces in it, and we could count them. But we're not going to do it that way because that's the elementary way to do it. We're going to do it mathematically, and we're going to think about what the pieces mean. So I'm going to write this a little bit larger just so I can make some notes around it. So first of all, I start with 5. I have 5 holes. Okay? In each of those holes, I have 7 pieces. The last couple years, I've used it as cases of beer. Let's say a case of beer comes in a pack of 7. You have 5 whole cases. Each case has 7 beer. The fraction part is, this is the pieces in the part set. Okay, so in the context of beer, we have 5 whole cases. Each case has 7 cans. That's what this bottom number tells me, the denominator. But we also have the fraction part, the numerator of the fraction tells me I have 2 cans in a part case. Okay, so in a part set. When I write an improper fraction, I want to write how many cans over how many in a case. Okay, so my numerator in an improper fraction is how many parts, the denominator is how many are in each set. So in order to figure that out, well, how many pieces are in the 5 sets? Well, I have 5 sets with 7 pieces. That leaves me with 35 pieces in the whole. 35 pieces in the whole plus 2 pieces in the part. Leaves me with 37 total. Okay, so if you need to think of it as cans of beer, as soon as I say cans of beer, everybody's able to solve these problems. If in terms of thinking of it in cans of beer, we've got 37 cans in total. So to write this as an improper fraction, we have 37 pieces that belong in sets of 7. The denominator will always stay the same as it was in the original. Now, I do have a little trick for solving these ones. Mathematically, and it works every single time, you are going to end up taking your denominator. You notice we took the denominator and we multiplied it by the whole number. Then we kept going and we added on the pieces for the fraction. That will give us every single time the number of pieces. So if we were to write this out as a formula, so we're going to take whole times denominator plus the numerator. I don't have enough space to write the whole words, divided by or underneath of what the denominator really was. So there's a little formula for you if you want a formula, but if you just think about what the pieces mean and think about 5 and 2/7, imagine that is cases of beer or cases of pop, whatever happens to be legal for you at the moment, tends to work for us. We're going to do a couple practice questions just to make it a little bit easier. This is the one that people usually get the hang of really quick. So we have 4 3/4. I want that written as an improper fraction. So I have 4 sets with 4 in them. So we're going to have 4 times 4 gives me 16 pieces, plus I have 3 extra pieces, which gives me 19. So the equal fraction is going to be 19 quarters. So an improper fraction is asking you for how many cans over how many belong in each case. Hopefully that helps out. So again, 4 times 4, start here and work your way around. This little trick tends to work quite well for people in terms of thinking through. B, 1 7/16. What is that as an improper fraction? If you're wondering why we're taking mixed numbers and turning them into improper fractions, we're going to need to do this when we multiply and divide. It's absolutely essential there. So we're kind of putting it in at the beginning because it's a good intro piece. But even though you're going to give your answer as the 1 7/16, we have to be able to go the other way as well. So we got to be able to do both of them. So you will see more reason for it after. So 1 7/16, I'm going to take 1 times 16. So these two get multiplied, plus the numerator, leaves me with 16. Notice order of operations. 1 times 16 is 16 plus 7, leaves us with 23. So the equal fraction is 23/16. Let's do the same thing here. We have 15 1/2. So we have 15 times 2, because there's 2 in each of those sets, plus 1 piece in a part set. Leaves me with 30 plus 1. 31/2. All right. And then for D, 2 5/8, same scenario. 2 sets with 8 in each set, plus 5 in the part set, equals 16 plus 5, leaves us with 21. 21/8 is our total. You'll notice in every single case, denominator has never changed. It always is the same. The numerator is the only thing that's changing. Okay? That's important to notice. The denominator never changes when you're converting. Now we're going to go the other way. We're going to take improper fractions and we're going to turn them into mixed fractions. This one tends to be a little bit trickier, and there's two ways to do it. I'm going to show you both ways of doing it. Just look and see if my calculator's here handy. All right. So we need to convert 14 fifths into a mixed number. So this is an improper fraction. Improper fractions will not work for final answers in SAM unless the question says leave as improper. Okay, so we need to be able to convert these. 14 over 5. I'll show you method 1. If you remember long division, it will probably help you with this question. I'm going to show you that way first. So 14 fifths is the same as saying, well, 14 divided into sets of 5. So remember seeing long division this way? For some of you, this is going to freak you out. Just bear with me. I'm going to show you the calculator version in a minute. Long division has a tendency to cause panic, but it's actually quite an easy way to show it. So 5 goes into 14 how many times? Well, 5 times 2 is 10, 5 times 3 is 15, so we're going to go with 2. So 5 times 2 is 10. We're going to subtract these 2, and that leaves us with 4 left over. We can't take any more away. So what does this all mean in terms of our fractions? Well, I have 2 sets of 5 because 2 sets of 5 gave me 10. So there's 2 wholes, and there was 4 left over that I couldn't put in another set of 5. So that's our 4 fifths. Make sense? So this is my set size for our denominator. This is the whole. And this is always going to be our numerator. Okay? Method 2. Everybody likes the calculator method. Okay. Let's say you don't know your multiplications and you can't stand long division. And it's been a while since you've done math, so long division just about gave you a heart attack. We'll do method 2, and we'll see how that one works out. We're going to do the same thing to start, though. In your calculator, I would like you to take 14 divided by 5. I want you to keep track of the entire decimal. So 14 divided by 5 leaves you with 2.8. 2 means there are 2 wholes. Okay? This 0.8, we're not allowed to leave as a decimal, because in a fraction chapter, unless you're asked to give a decimal fraction, you cannot leave a decimal in your answer. So how do we turn the 0.8 back to a fraction? Well, we take our 0.8, we're going to leave the 2 off because I know there's 2 wholes. I just need to put that part back to a fraction. We'll take 0.8 and we're going to multiply it by our denominator, so 0.8 times 5. Leaves us with 4. This is going to be my new numerator. So this leaves us with 2. There's my denominator. Here's my denominator again. So 4 and 5 on the bottom, 2 and 4 fifths. Hopefully I kind of wandered off question there. Hopefully that works. Sorry, I just used DEN for denominator. Hopefully that's enough of it for you to recognize it. It's a little tricky when you're trying to squeeze everything onto the screen. I don't have quite as much space as what I have on my blackboard or whiteboard, whatever it is I'm using. All right, so we're going to do another example because this does tend to be a little bit tricky for people to solve. I'm going to do it both ways. First, I'm going to use long division. So I've got 14 sixths. So 14 divided into sets of 6. Well, 2 times 6 is 12. We know there's not another set. So 2, let's subtract the 12. Leaves me with 2 left over. So this is equal to, if we look up here, we have the set size, that's my denominator, the whole numbers, and the numerator. So whole number, that's my 2 on the top. My denominator stays 6. You'll notice the denominator hasn't changed. Okay, the denominator hasn't changed in any of our final answers. And here the denominator is 6, the denominator is going to still be a 6. The numerator is what's left over down here. So this goes up to the numerator. So we've got 2 and 2 6. But wait, this is not in lowest terms, so we have to simplify. The question doesn't say it, it's just assumed in fractions that you will simplify. 2, and we only need to simplify the fraction part. The whole number stays the same, so you don't have to do anything with it, you can just write it down. 2 divided by 2, and 6 divided by 2, 2 and 1/3 is my final answer. Let's do it the other way. We'll do it the calculator way, okay? So we're going to do 14 divided by 6. If you put that in your calculator, you will get 2.3333333. Okay? Get all kinds of 3's. There's my whole number, okay? Now I'm going to take the decimal, I'm going to multiply it by the denominator again. Keep as many 3's as your calculator will allow. Keep as many of those decimals as you can. One way to keep all the decimals in your calculator without retyping them is when you see 2.3333333, just subtract 2 and it'll leave only the decimal part. And we're going to take that, we're going to multiply it by 6. And you will get an answer that, if it's not 2, it would be like 2.9998. We're going to round it to a whole number. It will give us 2. This is our numerator. So we have our wholes. The decimal gives us our numerator. So we have 2 and 2. The denominator stays the same, which is the same as 2 1/3. All right. That one's always a little bit more confusing, and if you don't understand it or if you're stuck with it, reach out to me. We'll get you some extra help on the topic. We're going to do just a few practice questions just to make sure that you've got things figured out. So 16/6. 16/6. So 16 divided by 6. If you want to use the calculator method, you can. I won't write out all the calculator steps. So 16 divided by 6, that goes in twice. Leaves me with 12 and 4 left over. So our fraction is equal to 2 and 4/6. So this is always my whole. This is the part. Okay. Again, we need to reduce that. So 2, I can divide these each by 2. And we get 2 and 2/3, and that will be our final answer. For B, we have 7/2. This is a really good one. If you see 2 on the bottom of your fraction, pop it in a calculator. It's a really good way to do it because 0.5 is a half. If you see 2.5, you can just go to the half. So we do 7 divided by 2, we get 3.5. Well, this is the benchmark. You should know that is equal to 3.5. So there are a few common fractions that are easy for you. 0.25 is a quarter. I may have to do an exercise with you pulling out a few of those fraction decimals. 23/10. How do we do that one? Well, let's set it up as division. 23 divided into sets of 10. So there are 2 sets of 10 in 20, gives me 20. And there's 3 left over. So 2 and 3/10. Or if you put it in your calculator and did 23 divided by 10, you'd see 2.3. 2.3, we read that mathematically. You learned that in the first lesson that we did with rounding and place value as 2 3/10, which allows us to write it. We can write it as a decimal, but we can take that decimal and write it in fraction form with 3/10 when we're required to do it as a fraction. And then so I'll put a box around that just because there's extra math on this. I'm afraid things getting a little messy. And then when we get to 30/8, So 30 divided by 8. How many times does 8 go into 30? Well, 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. So we're going to have to go with 3. 8 times 3 is 24. And then we'll subtract them. 30 minus 24 leaves me with 6. So we have 3. There's my whole. There's my part. So 3 and 6 is 8, which is the same as 3 and 3/4. Now there is another way you could do this one. You could have also decided, hey, let's reduce this right at the beginning. And we could have done that in A as well. So we could reduce this at the start and we could say, well, 30 over 8 is equal to 15 over 4. And you will still, even if you solve that, you will still get 3 3/4. Okay, so both of them are the same. I'll just put a note here, or reduce first. So that gives you a second option there. You could reduce at the beginning or you could reduce at the end, whatever happens to be easiest for you for that particular question. And there are times when I'll look at a question, I'll immediately think, oh, I should reduce this, it'll make it easier. And there's other times when I'll look at a question and I won't think to reduce it first. And finally, fraction rule number 2. Unless otherwise stated, never leave an improper fraction. Always give it in as a mixed number fraction. So the first rule is always simplify. The second rule is never leave fractions improper. And that finishes off our quick lesson on fraction basics.